Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 8, Lesson 5, on hyperbolas. So, we have four conics, and remember, they were circle, ellipse, hyperbola, parabola. We're not going to actually go over parabola, because that's exactly what quadratics is, so that was Unit 3, we already learned that. So that's why I'm not saying that on this one. So, the hyperbola, what is that? Well, the hyperbola, remember, it kind of looks like the parabola, but it's a little bit more bent, and it has two things that there are. Two parts of the graph. And it has asymptotes, and we remember asymptotes are something that the graph can't go by. We remember that from our rational unit. And, but the asymptotes aren't as simple because they're actually a line instead of just a straight up and down line or left and right line. It's a line that has a slope and a y-intercept, and we'll talk about that in a minute. But these are the equations, and there is a horizontal hyperbola and a vertical hyperbola. And here's how you know if one is the other. By this, if the x part is positive, then it's horizontal. If the y part is positive, then it is vertical. And this kind of looks a lot like the it looks like the ellipse one that we did in the last lesson, because it's the same, except for, remember, they have positive and negative. So that's the difference. And to find the asymptotes, we do b divided by a, x, so b divided by a is the slope, and then there's also negative b divided by ax. But also, you can just see something else that we'll talk about in a minute. And once again, for these purposes, a is greater than b. Sometimes teachers will switch it up and things like that, but we're just going to say that a is greater than b. Here's the steps for graphing hyperbola. Make sure that the equation is in the above format. So it needs to be in the thing that looks like this. But if it's not, remember, we have to complete the square like we did in the last lessons. Then you need to identify the center point, which, just like with ellipses, it is negative h, negative k. Then identify a and b and apply needed transformations of h and k to a and b. So this is kind of close to the same process as the ellipses. But you need to apply transformations, and once again, this will make sense later. And then graph the center point and the four vertices. Then you draw a box around it so that it looks like a rectangle, and that might sound weird, but that's a way to do it. And then you can draw the two asymptotes by finding them by using these formulas, or by just drawing them through the corners and through the center point, because that's what they do. And then you can draw the hyperbola around the asymptotes. Remember, if x is positive, horizontal. If x is negative, meaning y would be positive, then vertical. So, graph the hyperbola. Oh, of course, this is not in the form that it needs to be in, so we have to complete the square. Now, I forgot to make these squared, so just keep that in mind. It's not 2, it's squared. Because it's kind of hard to do that in one note. Okay, so let's do this. We need to make the like terms in the same thing. Oh, well, there's only one x term, so we'll just do that. And then we have plus 25y squared minus 100y equals, make the 125 on a different side, 125. Okay, now we need to divide by 25, so that coefficient can be 1, like it needs to be. So, y squared minus 4y, 4 divided by 2, 2, 2 squared, 4. And then we need to also add something to the 125, but not just 4, Remember I said you have to do 25 times 4 because you divide by that 25. So plus 100. So now we have negative 9x squared plus, we can change this to y minus 2 squared equals 225. Over here, this needs to be 1, so we divide by 225. Okay, and then we will see how this is. So 9 divided by 225 is, in fraction form, 1 over 25, so we can do negative x squared over 25 plus, we just have to keep this as it is, equals 1. Okay? Now, we can find some things here. We need to figure out the center point. Center point is, well, we see that there's no transformations for the x, but there is a negative 2 for the y, so that means 0, positive 2, because you have to change that sign. So that's the center. So then a is going to be the greater number, so 225 is a squared, so that means a is 15. B is going to be this, that b squared is 25, so b is 5. Alright, let's try to hurry this up. I'm under 10 minutes until I have to go on my meeting thing. Alright. I might not be able to do the last lesson yet, but I can do it later today. But, gosh, it's starting to get hot in this car. Even my iPad's getting hot. Alright, so then we have to have the vertices. The vertices will be, well, we'll have to apply transformations to them, but they'll start out as, well, actually, since the a was by the 25, or sorry, since the a is under the y, then actually it's going to be 0, 15. 0, negative 15. Then co-vertices would be 5, 0, negative 5, 0. I don't even think this graph goes to 15, so that's not good. We have to do our transformations. Since there's a 2 there, we need to add 2. So 0, 17, 0, negative 17. And then we have 5, 2, negative 5, 2. So that's our points. Now we need to graph the center and the vertices. That's what we say. And we're actually going to just change it. We'll make these by 2. Like, pretend like these are by 2s. So even though this might look like 1, 0, we're going to say that this is like 2, 4, 6 goes up like that. Since we have such big numbers. So then we have the 17 all the way up to 17. 4, 6, 8, 10, 12, 14, 16, 17. Then we have a negative 17 down here. Then we had 5, 2, negative 5, 2. Wait a second, I did something wrong. Yeah, I know that's not right. If you add 2 to negative 15, that's negative 13. Sorry about that. So let's fix that. Negative 13. Okay, that would be 17, 15, 13. That's better. Now we had a negative 5, 2, 4, 5. So we know this is going to be a vertical hyperbola because our y's were greater than our x's, or in that sense. And then I said to draw a box around the vertices so that, like this, it's not exactly even. And then we can do our asymptotes. We could just know that it would go like that, but we will just do our form b divided by a, and then negative b divided by a, and then we have a y-intercept of 2, since that was at 2, 0. So our b divided by a, so b divided by a, x plus 2, b divided by a, x, 2. And that means that our slopes would end up being, our asymptotes are, I'll just say, that would be 1/3 x plus 2, and then negative 1/3 x plus 2. Whew, hot in here. Very hot in here. Okay, now, since this is such a weird graph, I'm not going to, graph that exactly, but our asymptotes, I'll make them dotted. They would go like this. Okay, and since this is a vertical hyperbola, instead of our hyperbolas going like this, they will go up and down. So they will go like this. There will be one up here. Why isn't it drawing? Why isn't it drawing? Close to around like that, and then down here another one like that. And that there is how you figure out hyperbolas, graph them, change form, things like that. That's it for this video. Thanks for watching, and I'll see you on the next one.